All right, we are officially to the last section for Module C, in the last video presentation for Module C. All right, in this section, we're going to kind of look at some of the new things associated with this course in terms of radical equations and power functions. And in this particular section in video, we're going to go ahead and talk about solving radical equations and power functions. All right, so the first thing that we want to talk about is solving radical equations. This is something that we've been doing for the past two courses, and so this should be mostly review. In general, when solving radical equations, the first thing that we want to do is we want to isolate the radical. In order to get rid of a radical, we want to raise both sides of the equation equivalent to the exponent that is equivalent. So for instance, if you want to get rid of a square root, you square it. If you want to get rid of a cube root, you cube it, etc., etc. Something that we do want to keep in mind is we are going to be squaring both sides or cubing both sides. And so remember that if we are going to square a binomial, we do want to remember to FOIL or use the formula for perfect square trinomials. What we're going to do from there is we're going to repeat steps 1 and 2 if needed. And we want to finish solving the equation. All right, now one thing to note is that we do have a check step that might be required. If you have an index that is even, you are required to check your answer. It is possible, and we do have to do a full check on this one, it is possible that when we raise something to an even exponent, it can result in extra answers. And so we do have to go back and check them. In previous math courses, we've looked at level 1 difficulty and level 2 difficulty. We never got around to level 3 difficulty, and that is what we're going to do in this course. In this course, we're going to look at level 3. And level 3 deals with if you have more than one square root in an equation. If this is the case, then what you need to do is it technically doesn't matter, but a good strategy is always isolate the more complicated root in the first step. And that's one of the reasons that we do see up here repeat steps 1 and 2 if needed. This is when we're going to go ahead and see that. All right, so let's go ahead and look at solving some radical equations, and then we'll go ahead and talk about our power functions. All right, so we're going to kind of do a little bit of review, and then we'll go ahead and get into the more complicated examples. All right, so if we look at example A, we have x equals the square root of 5x minus 6. The first thing we want to do is we want to isolate our root, and it is isolated, so we can go ahead and proceed from here. In order to get rid of a square root, we are going to square both sides. And if we square both sides, we get x squared equals my square root and my square cancel, and I am left with 5x minus 6. From here, we want to go ahead and solve using appropriate techniques. And again, our basic techniques is linear or quadratic. Here, because this is a quadratic equation, we do have an x squared. We do want to get everything on one side of the equation. I'm going to move everything to the left, and if we do that, we get 5x squared minus 5x plus 6 equals 0. We can go ahead and factor this. This is a pretty easy factoring. We do have x and x. Things that multiply to 6 and combine to 5 is 2 and 3. We do have same sign since it is a positive 6. And we want them both to be negative since we want to combine to a negative 5. All right, if we set each factor equal to 0 and solve, we should get x equals 2. We want to add 2 to both sides. And I don't want to box it in yet. And we should get x equals 3. All right, the last thing that we want to do is we do want to go ahead and check these solutions. And again, this is a required step. And so we are going to go back to our original equation. And we want to plug in. So if we go ahead and check 2, we get 2 equals the square root of 5 times 2 is 10. And we want to subtract 6. All right, 10 minus 6 is 4. And the square root of 4 is in fact 2. And so this one does check out. We keep it. All right, let's check the other one. If we plug in 3, we get 3 equals the square root. If we multiply 5 times 3, we get 15. 15 minus 6 is 9. And the square root of 9 is 3. This one checks out, and so we can go ahead and keep this answer as well. All right, this is our first example, so now let's go ahead and look at one more basic one. Let's come over to example B. All right, example B is going to be a cube root, but we still want to kind of follow the same process. The first thing I want to do is I want to isolate my root. And so anything that is outside the root, we want to go ahead and subtract it or move it to the other side. So I'm going to get rid of my plus 4. It is not inside the root. And we get the cube root of z plus 1 equals negative 3. All right, so just like we square to get rid of a square root, to get rid of cube root, we want to cube both sides. If we cube both sides, on the right, my cube root and my cube cancel out, and I am left with z plus 1. And if we cube negative 3, we should get negative 27. Finally, we want to finish solving for z. We can subtract 1 from both sides, and we get z equals negative 28. Now, it is a good idea to check your solution, just to basically check your work. But here, when we talk odd roots, we are not going to have any extraneous solutions. And so whatever answers we get, we keep them. Okay, so that's kind of a review of some of our basic level 1, level 2 type problems that we look at when we talk about solving radical equations. Okay, so now we're going to get into level 3, and these are going to be the hardest ones that we're going to look at in terms of solving radical equations algebraically. So we're going to come down to example C. And for example C, we have 2 square roots. We're still going to follow the same basic process. So the first thing that I want to do is I want to isolate one of my square roots. And as I mentioned in the procedures, we want to isolate the more complicated one. And ultimately, you know, are they really all that much more complicated than each other? Not really, okay? But we're just going to go ahead and isolate one of them. And so what I'm going to do is I'm going to isolate my square root of 2x plus 3. We get that this is equal to 1 plus the square root of x plus 1. And I'm going to write it in this order just so it's very clear what's inside the square root and what's not. Okay, from here, we're going to do like we did before. I want to get rid of my square root, and so I am going to square both sides. Now, we do have to be careful on the right side because we need to FOIL this. All right, so if we FOIL this, or on the left, let's start with the left side first. My square and my square root cancel. We are left with 2x plus 3. Now on the right, we're going to go ahead and FOIL. So we're going to start with our firsts. If we multiply our firsts, we get 1 times 1 is 1. Now when we deal with these square roots, don't worry so much about what they are, okay? If we multiply 1 times something, well, we just get that something. And so what we end up with here is plus the square root of x plus 1. If we do our insides, it's going to be the same thing, okay? Because it is a 1 that we're multiplying by, we don't have to do anything fancy. It's just going to be the square root of x plus 1. And then the last one, our lasts, what we get is the square root of x plus 1 times the square root of x plus 1. And basically, what we have here is this is equal to the square root of x plus 1 squared. Well, we still have that same rule, squares and square roots cancel. And so what this becomes is x plus 1. All right, if we go ahead and simplify, we want to combine our like terms. And so what we get is 2x plus 3 equals. I can combine my 1s. This becomes a 2. I have a plus x over here. And then I can combine the square root of x plus 1 and the square root of x plus 1. And so when we combine these, how many square root of x plus 1s do we have? We have 2. And then we go ahead and repeat the process again. So I want to isolate my square root. In order to do that, I'm going to subtract x from both sides, and I'm going to subtract 2 from both sides. I want to get everything that's not in that square root of x term to the other side. All right, if we do this, we get x plus 1 equals, we have our 2's cancel, our x's cancel, and we are left with 2 times the square root of x plus 1. Now, if you want, you can divide by 2, but I'm not going to, just because I'm going to have to deal with fractions, and I just don't feel like dealing with fractions right now. But we can go ahead and square both sides. And the important thing to remember here is that we are still going to have to FOIL again on the left because it is a binomial. And if we FOIL this, we get x squared plus x for our outsides x for our insides, and 1 for our lasts. Now on the right side, we do need to square the whole thing. And the main thing is we need to square the 2 as well. And so when we square the 2, we get 4. And here we do get that my square root and my square cancel out, and we are left with x plus 1. All right, we can go ahead and combine our like terms. On the left side, we get plus 2x plus 1. On the right side, I can distribute, and we get 4x plus 4. And then we do have a quadratic equation, so we want to get everything on one side. So I'm going to move everything to the left. And if we do that, we get x squared minus 2x minus 3 equals 0. Okay, we're almost there. We want to go ahead and factor. X squared is x and x. Things that multiply to 3 are 3 and 1. And I do want my larger number to be negative since I want it to combine to a negative 2. All right, if we set each factor equal to 0, we get x equals 3. And if we set our second factor equal to 0, we get x equals negative 1. Okay, we are not done. We have to check this. And so we are going to go ahead and plug these back into the original equation. And let's see what happens. All right, if we start with the 3. If we plug this in, we get 2 times 3 is 6. We still have our plus 3. All right, we go ahead and plug into the second one. We get 3 plus 1. And I want to know, is this equal to 1? And so when we simplify this, 6 plus 3 is 9. 3 plus 1 is 4. And when we take the square roots, we get 3 minus 2 equals 1. That does check out. And so what that means is I can go ahead and keep my negative 3. I'm sorry, keep my positive 3. All right, we also want to check negative 1. And so if we plug in negative 1 to our original equation, we get the square root of 2 times negative 1 is negative 2 plus 3 minus the square root of negative 1 plus 1, and I want to know, is this equal to 1? All right, negative 2 plus 3 is 1. Negative 1 plus 1 is 0. And if we take the square roots, we get 1 minus 0, and that is equal to 1. And so both of these answers are okay. All right, now, as this is a new type of problem, we're going to go ahead and do one more example to get a little bit of practice with this. All right, let's come over to example D. And I'm going to rewrite it so that we have a little bit more room. All right, we have the square root of x equals the square root of x minus 5 plus 1. It does tell us to isolate the more complicated radical, but I do want to show you that it really does not matter all that much. So because I already have one of them isolated, I'm going to go ahead and just leave it as it is. I want to square both sides. And if we square both sides, on the left we get x. On the right, we do want to FOIL. And if we FOIL this, we get, for our firsts, the square root of x minus 5 squared, which is x minus 5. All right, we want our outsides. This becomes plus the square root of x minus 5 because we're multiplying by 1. Insides, we also get the square root of x minus 5 because we're multiplying by 1. And our last, we get 1. All right, we want to go ahead and simplify this. So we get x equals x. If we combine our constants, we get minus 4. And then if we combine our square root of x minus 5s, we get 2 square root of x minus 5. All right, I'm going to go ahead and isolate my root again. So I'm going to go ahead and subtract x and add 4. When we do this, we get our x's cancel, and I am left with just 4 equals 2 square root of x minus 5. And for this one, I am going to go ahead and divide. The main reason is because I can. Okay. It doesn't make my problem any more complicated. Dividing by 2, I get smaller numbers. I'm not having to worry about fractions, and so for this one, I am going to go ahead and do that. All right. What we're left with is 2 equals the square root of x minus 5. Okay, we're going to go ahead and square. And what we get is 4 equals x minus 5. And we can add 5 to both sides, and we get 9 equals x. All right, we do want to check this in our original equation. And so if we plug this in for x, we do get the square root of 9 equals the square root of 9 minus 5 plus 1. Square root of 9 is equal to 3. If we do 9 minus 5, we get 4. And the square root of 4 is 2. And if we add 1 onto that, we do get 3. Sorry, that's not my answer. That was my check step. And so we do get x equals 9, does work in the original problem, and we keep the answer. I do recommend, if you can, go back and watch some of my other videos from Math 1215, Intermediate Algebra, or even CCDM 114, where you can see examples where when we plug our answers in, we may get statements that are not true. Okay, and so even though all of these, they all worked, that is not always the case. All right, that is solving radical equations. And as I said, example C and D, these are some of the more complicated versions. These are the most complicated versions that you will run into in terms of algebra classes. All right, the next thing that we want to talk about is something called a power function. A power function is a function given by the formula, or by the function, f of x equals x raised to the b, where b is a constant. There are no restrictions on b except for that it has to be a number. So for instance, in several of our examples that we've talked about so far, if b is a fraction where n is greater than or equal to 2, then f is also a root function. F of x equals the nth root of x. They are equivalent. Now, power functions is just another way to describe a function. So, for instance, examples of power functions, f of x equals x squared is a power function. G of x equals x to the 3/4 is a power function. H of x equals x to the 0.4 is a power function. Roots are power functions. We can rewrite them as x raised to something. We can also have negative exponents. X to the negative 2 still satisfies the requirement. Basic rational functions, for instance, like 1 over x to the 4th. This is a power function because I can rewrite this as x to the negative 4. And so negative exponents, remember, are reciprocals, and fractional exponents are roots, okay? And so why do we do this? Well, it's because, it's partially because we can. We can define a function in many ways, many different ways, just like we can define numbers in different ways. For instance, if we look at the number 5, there's lots of ways that we can categorize this. It is a one-digit number, it's an odd number, it's a prime number, and so we can do the same thing with functions. If we look at the function f of x equals x, this is a linear function. It's a polynomial function. It's a power function. It's an odd function. It's a one-to-one function. And so, we just want to keep in mind that when we look at these functions is that they don't always just fall in one category. They can fall in several categories. Now, when we talk about power functions, we can still shift, stretch, compress, and reflect. Now, one of the things that we do want to keep in mind is not all polynomial functions are power functions. Basic cubic, basic quartic, quintic, whatever, these are all examples of power functions. But if we have a cubic function or even one of those crazy quintic functions that did all sorts of crazy things, that is no longer a power function. Okay, and so when we talk about it from these different perspectives, we have to keep in mind, what are we looking at? Okay. All right, so let's go ahead and talk about a little bit more with power functions. All right, so though this is not a high priority topic, we do want to talk about solving equations involving power functions. The first thing that we want to do is we want to isolate the variable with the exponent. And we can do a couple different things here, okay? We can use the rules that we discussed in the last video to write in terms of radicals or fractions, and then we can finish solving for x. We do want to be very careful here because we do have the rule. We still need to make sure that we remember the rule that if we take a square root or an even root of any kind, remember that we do have to include a plus or minus. All right, so let's go ahead and look at some examples of this so that we can see kind of what we're doing. All right, if we come to example A, we have x to the 2/3 equals 16. Now this is what I'm going to do. I'm going to do this two different ways. I'm going to start by rewriting this exponent as a root. So when we do this, remember that the numerator is going to stay with our variable. The denominator becomes the index. Another thing that we can do is, I really don't feel like cubing right now first. Remember that the exponent and the index, there's really no set order on how we have to do this. So for instance, I can look at this as the cube root of x squared. Or I can look at this as the cube root of x squared. They're the same thing. All right. I did it this way because I would rather get rid of the square first. And so if we take the square root of both sides, my square and my square root cancel. We are left with the cube root of x. And remember, because we did take the square root of both sides, I do want to go ahead and include the plus or minus. All right, we get plus or minus 4. All right, the next thing that we want to do is we want to cube both sides. And if we cube both sides, my cube root and my cube go away. And what we are left with is x equals, if we cube positive 4, we get 64. And if we cube negative 4, we get negative 64. And so we get two answers, which is plus or minus 64. All right, this is one way that we can do this. I'm going to show you another way that we can do it, and it's basically going to boil down to the same thing. All right, so if we go ahead and come back to our original equation, we have x to the 2/3 equals 16. In order to get x by itself, what I want is I want an exponent of 1. That's basically x by itself. In order to do that, what I want to do is I want to raise this to the reciprocal. The reciprocal of 2/3 is 3/2. And remember that when you raise an exponent to another exponent, you multiply them. Well, if we multiply 2/3 times 3/2, they cancel. Well, whatever we do to one side, we want to do to the other. So we do want to raise this to the 3/2 as well. Now, from here, we're going to go ahead and do what we did previously. I want to go ahead and translate this. Now, my numerator of my exponent is a 3. My denominator is a 2, which means that it becomes a square root. And remember the rule. Whenever you take the square root, when we're doing something like this, we do have to do plus or minus. And same thing again, it doesn't matter whether you cube first or square root first, we're still going to get the same answer. But if we take the square root of 16, we get 4. We do have plus or minus, and we want to cube this. And we do get plus or minus 64. Same answer. So ultimately, we do have to convert to roots at some point. It's just a matter of, do you want to do it at the beginning or do you want to do it at the end? Me personally, I will say for this particular problem, and you have to be very cautious, you really want to think about, do I need to include that plus or minus? And for me, when on this one, I do like writing it as the left side of the screen. I have a hard time when I'm doing this one. I do have a tendency to forget that I have to take the plus and minus. I am usually only used to doing plus and minus when I take the square root of both sides. And so that's one of the reasons that I do like doing this one based on the left side. All right, let's go ahead and look at one more example and see what we can do with it. All right, if we come to example B, the first thing we want to do is we do want to go ahead and get our variable by itself. So I'm going to start by moving everything to the other side. So I'm going to subtract 5. We get 4x to the 3/2 equals 16. I can divide by 4. And we get x to the 3/2 equals 4. All right, so the first thing that I'm going to do is I am going to go ahead and convert this into roots. So when we look at this is saying x cubed, the square root, equals 4. So in order to simplify or solve this, the first thing I want to do is get rid of the square root. I'm going to square both sides. We get x cubed equals 16. And then we want to take the cube root of both sides. And we can break this down. Okay. 16, this is equal to 8 times 2. 8 is a cube. And if we take the cube root of 8, we get 2. And we still have that 2 on the inside that cannot come out. This is our final answer. Notice here we took a cube root of both sides, which means that we don't have to do plus and minus. Remember that we only do that with square roots or even roots. And so this one is pretty straightforward. We don't have to remember any tricks or anything like that. All right, let's go ahead and practice doing it the second way. So for instance here, we have x to the 3/2 equals 4. To get rid of an exponent of 3/2, I want to raise it to the 2/3. Want to raise it to the reciprocal. And what we get is 3/2 times 2/3. They cancel out and we are just left with x. Now, in terms of the homework, because this doesn't simplify down to a nice number, make sure that you pay attention to how it wants the answer. It very well could be that this is perfectly fine. Because it is a root that does not simplify, that might be an okay answer. Okay. But I do want to go ahead and simplify this. And so what we're going to do is, again, we're going to go ahead and rewrite this using roots. My denominator becomes my index. and my numerator becomes my outside exponent. And for this one, because I can't do cube root of 4, it doesn't simplify, I'm going to go ahead and put my square on the inside. If we do this, we do get the cube root of 16, and we are back to breaking it down. All right, that finishes our power functions. As I mentioned, this is not a high priority topic, but just so you know, if you do hear the word power function or the term power function in your future math classes, that's basically what we're talking about here. All right, that finishes off this section. That finishes off Module C. And we have one more module to go before we get to the end of the semester. Let's all hang in there.